and subtract polynomials. Problem number 1, add. So we have negative 5y to the 7th power plus 2y to the 5th power minus 3y to the 3rd power plus 9y to the 2nd power, and all that is added to 2y to the 7th power plus 5y to the 3rd power plus 11y to the 2nd power. Now, when we are adding or subtracting polynomials, we must have like terms. That means like terms are terms that consist of the exact same variable with the exact same degree, which is the exponent. So for example, if we have y to the 7th power, then the like term that we can add or subtract it to needs to have the same variable as here, y, and also the same power as 7. So we can add the coefficients, the numbers in front together. In this case, negative 5 plus 2, and we get negative 3y to the 7th power. When we are adding and subtracting like terms, this is the reason why we need the same variable and the same exponent, because they will stay the same. Now let's move on to the next term, which is 2y to the 5th power. And if we look at the second set of terms, we don't see another term that has y to the 5th power. So we're just going to bring this term down, 2y to the 5th power. Now, y to the 3rd power does have a like term in the second set of parentheses, so we add the coefficients together. Negative 3 plus 5 gives me positive 2y to the 3rd power. Again, the variable and the exponent stay the same. Now our last term, y to the 2nd power, we do find a match, and we have y to the 2nd power in the second set of parentheses as well. So adding these two together, we get 20y to the 2nd power. Now we can double check that we simplified completely by looking at our variables and the exponent to see that there are no other like terms. So we only have one y to the 7th power, only one y to the 5th power, only one y to the 3rd power, and only one y to the 2nd power. So we are done adding these two polynomials together, and this represents our final answer.